Welcome to one and all for the Unit 1 Metal Crystal Structures of Metallurgy of Welded Joints, this session 5. That is, let us start with Miller indices. So, what is Miller indices? What do you mean by Miller indices? So, in this sketch you can see there is a crystal in which there is a planes. So, these planes are known as crystallographic planes. So, a Miller indices indicates the crystallographic plane in a unit cell. So, this crystallographic plane is nothing but x-axis, y-axis and z-axis. The three axes, the three-dimensional object, three axes. So, in which plane the crystals are arranged. So, this is very important. So, this identification will help us for identification of the volume of any object. So, let us see. A Miller indices means it indicates the crystallographic plane in the unit cell. So, this Miller indices describes the relation between certain planes in atomic structure. It is going to indicate the relationship between certain planes in an atomic structure. So, this is very useful for us while any identification of any kind of a defect, in which plane, in which side of a metal there is a defect. So, this is very important for us. So, for measuring purpose, for measurement of any crystal, we are going to consider this type of things. So, these planes are numerically infinity expressed by three coordinates. As I said, x, y and z. It is a 3D model, 3-dimension model. Miller index is 0, 0 for x, y, z. As I said, so the center of the axis starts from reference, just like a graph. When you start graph x and y, the coordinates we will call it as 0, 0. That's a reference. We will every time you start with a reference, that is 0, 0. For example, the coordinate 0, 0 indicates that x-axis is indefinite 0, y-axis represents y unit from the origin, z-axis is also infinity. Means what does it means? Means x is 0, y is 0. X is 0, z is 0. What is y? 1 unit. Oh, y is 1 unit. So, if in this sketch you can see, what does it mean? So, 0, 1, 0 I can call. 0, 1, 0 means x is 0, y is 0, z is 0. Suppose if x is 1, what does it indicates? If x is 1, it is if 1, 1, 0 means x is 1, y is 1, and z is 1. Okay, so this is a difference that it is being given. So, in a Miller indices 0, 1, 0 means it is x is 0, y is 1, z is 0, 0, 1, 0. I can explain in this way. So, this is a 3-dimension. So, it is usually used to get 0, 0 for x and y only, or y and z, or zx, whatever the combination you take. When there is a 3 axis, there will be 3 decimals 0, 1, 0. So, it indicates the corresponding axis. Next is what is known as dendrites. What is a dendrites? In a simple word, when I say, what happens when the metal starts solidifying? What is solidification? Solidification means the process of converting from liquid to solid. What we will do for solidification? We are going to cool. We are going to dip it in a water or a quenching medium or a salt bath, whatever it may be. So, depending upon the medium which we use, the hardness changes. Similarly, in this, while cooling, what happens? Most metal solidifies in a set of sequence established by temperature loss processing process. Temperature loss processing from a liquid state. When it loses its temperature, what happens? The grain growths are formed. So, these grain growths are known as what you will call it as dendrites. In a simple words, the grain growth is known as dendrites. In the first sketch, you can see when the initiation of a cooling takes place, a small growth is formed. further the cooling process continues, you can see in the second sketch, the growth is bigger. Once comes to the third stage, further cooling, 50% cooling I can say in this third case, growth increases. When you see 75% cooling, the growth is huge. When you cool at a 100% cooling, the growth is complete. The growth is complete. New crystal structure is formed. So when you heat the metal above recrystallization temperature, all the crystallines, when you cool it, all the crystallines will become refined structure. The crystals will be refined. So that is why it will have more strength than the any other. Before heat, why heat treatment will be done generally? Why heating will be done? To refine improve the properties of a material. By heating, the properties of metal will improve. How it will improve? The atoms will be loosely packed. When you heat it out, the atom starts freely move and will accommodate any gap between the metal or atoms. So it becomes more strength, and the strength of the metal will be huge, very good strength. So individual atoms of a metals in a liquid state exhibits a extremely free movement to a state of completely rigid body. So the metal passes through three types of crystal structure which are based on dendrite growth during the sequence. Dendrite growth during the sequence. The metal passes through three types of crystal structure. So you know that what are the different types of crystal structures, right? So let us see what are the sequence of operations in the dendrites. So here you can see there are three sequences in this. Dendrite may be compared in appearance like trunk and limbs of a tree. ಯಾವ್ದಾದ್ರು ಈಗ ಒಂದು ಗಿಡ ಬೆಳಿಬೇಕಾದ್ರೆ ನೋಡಿರ್ತೀರ, ಈ ಸೈಡಲ್ಲಿ ರೆಂಬೆ ಕೊಂಬೆಗಳೆಲ್ಲ ಬಂದಿರುತ್ತೆ. ಸೊ ಈ ಚಿಗುರನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಡೆಂಡ್ರೈಟ್ಸ್. ಇಟ್ ಅಪಿಯರ್ಸ್ ಲೈಕ್ ದಟ್. ಈ ಅಪಿಯರೆನ್ಸ್ ಯಾವ ಥರ ಇರುತ್ತೆ ಅಂದರೆ ಇಟ್ ಈಸ್ ಲೈಕ್ ದಟ್, ಅಂಡ್ ಇಟ್ ಇಸ್ ನಾಟ್ ವಿಸಿಬಲ್ ಬೈ ಯುವರ್ ನೇಕ್ಡ್ ಐಸ್. ವಿ ಹ್ಯಾವ್ ಟು ಯೂಸ್ ಎ ಟ್ರಾವೆಲಿಂಗ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ to check whether the growth has formed or not. It is not possible with your naked eyes, just like a trees or something like that. With the visibles like that, imagination, you can imagine that like the growth, the initial growth of a plant will be like this. So dendrite growth begins with the nucleus. It starts from the center. It starts from the center of the nucleus, which proceeds to the growth to a skeleton form. It fills in addition metal until the crystal is completely filled. So it starts from the center and it will occupy the entire area volume of a metal, and it will give a new shape to the material, new property to the material. This nucleus begins crystalline growth. This initiation of these crystal growth is known as crystalline growth. So the primary axis shows that the first portion is formed as the temperature of both decreases. Here in this case, first sketch, you can see what happens in this is a crystal structure. So this is the first axis. So the first axis shows that. Here the first axis shows that. The primary axis shows that. Okay. So it is partially 50% it is formed. Whereas the second axis is further heat loss. Second axis is formed with further heat loss, means the growth is almost or completed. So at this point the crystal structure is completed. In the last sketch I explained how it is formed. Initiation, then it grows and grows. Further the cooling is, when the cooling is going on, what happens? When the cooling further is carried on, so the grain growth is increasing. So when the temperature loses in a metal, grain growth is increasing. So this is how it is going to form. Dendrite means it is a growth, crystalline growth in a material. Further, further the process or cooling is carried out, the growth increases. So this is what you understand. This is a schematic representation which I show. Let us see what is cooling curve. What I am explaining here is, as I said, any metal in a liquid state should be converted to solid state, means cooling process takes place. While cooling, there are three physical changes we observe in a material. The solidification process, the cooling process is known as solidification process of metal, goes through three physical changes in crystalline structure of a material. First one is liquidus. Second one is liquidus solidus. Third one is solidus. Liquidus, solidus. What is liquidus? First stage is liquidus. At this point, as the name indicates, at this point the crystal structure begins to form. It will be in liquid state. It will be in liquid state. From that point, it starts forming the crystal. Second stage is liquidus solidus. Second stage is here. The first stage is this liquidus. So if you see here, temperature from liquidus to liquidus solidus, the temperature is decreasing, time is increasing, temperature decreases over a period of time. This is what temperature and time curve it is. So while cooling, what happens? The temperature decreases and the time increases. Temperature decreases and time increases. So this type of thing we will call it as liquidus solidus is a point in which temperature and the time at which metal is in semi-liquid state. At this stage we will call it as semi-liquid stage. Okay, so it is in a semi-liquid state. Next is, you will call it as intermediate state also, you can call it as that. Next, last stage is known as solid stage. Here you can see from liquid as solid to solid state, it will be 50% solid and 50% liquid at this stage. So further cooling and as the time elapses, you are going to form a solid metal. At this point, the grain growth formation is complete. And the metal in a solid, even though it is still in hot, even though it is in a hot condition, it will be in a solid state. At that point, it becomes a solid. At that point, the crystal formation is completed. Crystal formation is completed. So I hope you understand. There are three phases. One is liquid, liquid and solidus. Liquid state is completely in a liquid state. Means it is in a form of a liquid. Whereas in a liquid solid state, further when you process starts cooling the metal, it forms a intermediate state known as 50% liquid and 50% solid. So your temperature decreases, time increases. When further cooling, what happens? It completely forms a solid, and here it is 100% solid, even though it is in a red hot condition, but it is formed as a solid metal. Let us see the heat evaluation technique. Why heat evaluation is necessary now? And I said cooling. When you start cooling, what happens? Heat is rapidly removed away, taken off from the material. When the temperature decreases, means heat is removed off. The heat evaluation is the state of solidification. In other way of cooling, we will call it as heat evaluation. It is, when does this heat evaluation start? It is a starting of solidification. Solidification means freezing, cooling, converting from liquid to solid. Heat evaluation is the start of solidification. It is the point in a time on the temperature at which dendrite growth begins. From liquid, when it starts becoming a solid, then the growth forms. Dendrite growth is formed. Dendrite is a kind of a, just like a trunk and limbs of a tree. It appears like that, but you should imagine, and it will be similar fashion like a plant. It will be in a metal. The growth takes place. The transformation of free atoms to an entrapped ones within a dendrite structure releases energy in the form of a heat. How the heat is removed, how the heat is coming out? While for transformation of free electrons to entrapped ones, wherever there is a gap, there it is going to go and settle. During this settlement, what happens? Dendritic structure releases energy. So energy is released from the dendritic structure in the form of heat. This heat is coming out, which prolong for a cycle time between the liquid and a solid stage. So while liberating the heat happens, heat is lost and it is converting into solid. And this stage is liquid solid stage, which is the intermediate stage. This process of reheating is known as superheating or supercooling. See here, this process of reheating, what you are going to do, you further heat. As I said, once it is when the cooling starts, you are going to further cool it, further reheat it. This process is known as superheating or supercooling also, we can call it as that. Why you are going to do that? Because in order to freeze it completely, in order to form a solid. So these crystalline growth resulting in heat evaporation, which is shortly lived because heat dissipation depends upon particular metal. So each metal has its own heat dissipation characteristics. Emissivity we will call it as ability to give back the heat. So each metal is have different crystal structure, and each metals will have different heat dissipations depending upon that. So this is a kind of heat evaluation technique. So in this class we saw what is Miller indices, a crystallographic plane, and we saw what do you mean by dendrites, how the dendrite growth is formed, and we saw what is cooling curve, how the metal starts solidification process, and how the heat is removed away, So this is some kinds of necessary things. Let us see the model question papers. Okay, the first session, dash indicates the crystallographic plane in a unit cell. A, Miller indices, B, secondary, C, surface, D, volume. What's the answer for this? Miller indices is the right answer. Miller indices indicates the crystallographic plane in a unit cell. Next, crystallographic plane are numerically expressed by how many coordinates? 1 coordinate, 2 coordinate, 3 and 4. What is the right answer, students? It is a C, 3 coordinates, X, Y and Z respectively. Third question, during solidification process, the metal temperature dash increases, decreases, constant, none of this. What is the answer for this? It increases, decreases, constant, this. What is solidification process before? Solidification process means the process of decrease in temperature. It cannot be constant. I'm just checking whether you know it or not. The answer is decrease in process. Whatever they have written, that is not right. But you should understand the concept now. During solidification process means during cooling process, what happens to metal temperature? Decreases. So answer is B, decreases. So next is, let's see what is known as D. So question number D. Solidification process increases metal. What is it going to increase? Metal is going to get rigid. Means it is going to become solid. So what does it increase? It increases the rigidity. Answer is right. A, rigidity. It is not going to increase thermal expansion, heat or whatever it is. Okay. So it is going to increase the rigidity. A growth of a metal appears to the trunk and limbs of a tree, which is known as, what is this term known as? Heat affected zone, defect, dendrite, crystal. Answer is dendrite. Nucleus begins with what? Crystal structure, defect, dendrite, crystal. It starts with a crystal growth. The technical word is crystal growth. The process is known as dendrite. I am not speaking about that. Nucleus begins with what? It is known as crystal growths. Okay. So next is a point at which the first crystal structure begins to form, which is the first stage of the cooling curve. It is liquidus. Okay. The point at which temperature and time metal is semi-liquid state. This is the intermediate state. Which state it is? It is a liquidus and solidus. Liquidus solidus is the right answer for this. For next, question number 9. A point at which grain formation is complete. The complete stage is known as what? Solidus. Initial, intermediate, final is completed stage is known as solidus. Last question, dear students. The process of reheating or recooling, all those processes known as what? Superheating. Superheating is known as the process of reheating. Okay, dear students, thank you so much for your patience listening. Okay, thanks one and all.